Okay, now it's chapter 3, Laplace transform. So what is the definition of Laplace transform? So first of all, this is a transform named by a person, Laplace. So some people pronounce it as Laplace. So it's up to you, okay? So for me, I'll pronounce it as Laplace transform. So if you have a function ft, okay, meaning it's a function of t. So if you want to perform the Laplace transform of this ft, meaning what we need to do? Meaning we need to do the integration here. Okay, we need to substitute the ft, okay, the function of t, in this integral. Integration from 0 to infinity e negative st ft dt. So if you obtain the integral, meaning the integral exists, so we say that the Laplace transform exists. And how do we write it? For example, you have ft can be just a constant a, meaning a number 2, 3, 4, 5, or maybe just t power 1, okay, t power 2, power n, or maybe exponent of t, okay, exponent negative t. Maybe you have sine t, cos t. Okay, the worst is maybe you have the combination. Maybe you have exponent t, cos t. Okay, so these are all function of t. So for example, if you want to find the integration of the Laplace transform of ft equals to 3, so you will find Laplace of 3 is equals to integration from 0 to infinity exponent negative st, okay, and then times 3 dt. So you will solve this, okay. So the Laplace, the operator for Laplace is this one, okay, the special L here. So normally I like to write like this. So it's up to you, as long as you don't write as the normal L, okay, make it a little bit different, okay, maybe like that, okay, that. It's up to you. Is the Laplace operator. Okay, if you want to find the Laplace of ft equals to t, so your integral becomes from 0 to infinity exponent negative st t dt. So if ft equals to exponent 2t, maybe, so the integration will always from 0 to infinity e negative st. So we just change the ft. Okay, so that's it. So that's how you do it, the theory. So now we are going to see the example on how to solve for the integral. Okay, so example 1.1. First, ft equals to a. So using the definition, determine the Laplace transforms for the following function. Okay, we need to use the definition just now, so which I've written it again here. So ft equals to a. So Laplace of a, okay, remember the operator is equals to the integration from 0 to infinity exponent negative st, okay, a dt. So a is just a constant, okay. So I hope you still remember how to do a definite integral, how to perform a definite integral. So it will just be negative a negative st, sorry, okay, will be negative st, okay, a is there, divide by the negative s, okay, divide by the constant, the power of the exponent from 0 to infinity. So we solve it, the upper limit minus the lower limit, so it will be a exponent negative infinity divided by negative s minus a exponent 0, okay, divided by negative s. So be careful here. exponent infinity, exponent negative infinity. So we to avoid confusion, you can bring the exponent here below, bring it down. Okay, so it'll be negative a s exponent infinity minus a over s, which is positive s here. So exponent infinity, so exponent power infinity, what do you get actually? Exponent, the graph of exponent will be increasingly, right? So if power exponent maybe is approaches a very big number, so a is just a small number, a constant, divide by a very big number, okay, you'll get equals to 0. Okay, here a divided by infinity will be 0 here. So Laplace of a will just be a over s. Okay, that's it. This is the Laplace transform of a. Okay, for b, we want to perform the Laplace transform for ft equal to t. So we write the integration first from 0 to infinity exponent negative st t dt. So in this case, this is a combination of two functions of t, right? T is a polynomial and t is a exponential function. So this one you need to perform by part or tabular method. Okay, now for this example, I want to show on the tabular method. Okay, so positive t exponent negative st, so negative 1 positive 0. So exponent negative st divided by negative s, and then exponent negative st divided by s squared. So the result will be t exponent negative, okay, t minus exponent negative st over s, right? Okay, wait. Okay, let's continue on the next slide. Okay, let's continue. So the result for the integration is negative t exponent negative st divided by s minus exponent negative st divided by s squared. So now we want to put the integral, yeah. So negative st divided by s minus exponent negative st divided by s squared from 0 to infinity. Okay, first we need to substitute for both terms, yeah. So Laplace of t is equals to, okay, first we substitute infinity, negative infinity exponent infinity negative infinity divided by s minus exponent negative infinity divided by s squared. Okay, and then minus the lower limit will be 0, okay, over s minus exponent 0 over s squared. So how are we going to solve this one? So this the first term, exponent negative infinity, exponent negative infinity is actually exponent infinity over infinity, okay, which will approaches 0. You'll get 0. So this one is 0. This one is 1 over infinity. So this is actually right below here, infinity over infinity minus 1 over infinity. This is 0, this is 1 over s squared. So this one is 0 to 0, so just left with 1 over s squared. So the Laplace transform for t is just this one. So that's it. You need to take note on how to find the integral. Yeah. So next, okay, B. So I'm going to skip this example. Okay, we will learn it in the later topic. Okay, I'm going to show for this one. So Laplace of exponent at is equals to integration from 0 to infinity exponent negative st exponent at dt. So before we perform the integration, you might want to combine the term because it's both are exponential. So it will be a minus s power multiplied by t. Okay, so you now know how to integrate this, right? So it will be exponent, okay, the same thing, divide by the power, the coefficient of t, okay, from 0 to infinity. Next, we substitute the limit, you will get it equals to exponent a minus infinity, a minus s, substitute on t, divide by a minus s minus exponent a minus s times 0 divided by a minus s. So we'll continue here. It's equals to a minus s times infinity exponent infinity divided by a minus s, okay, minus exponent 0 divided by a minus s. It's going to be negative. Okay, I write like this to make it, to avoid confusion. Okay, how do we write this one? Okay, for the first term, so it's actually like this. Okay, this is a exponent, right? So when we separate the exponent negative s infinity, we bring the s below down here. Okay, now exponent 0 is 1 over minus s. So again, this is infinity over infinity, which is it is equal to 0. So it's negative 1 over a minus a, we can write it as 1 over s minus a. Okay, you multiply the negative inside the fraction, so we obtain it equals to this one, Laplace of exponent a okay, is it? So now, by using the definition, you want to solve the piecewise function. So this ft, we have many ft in one many interval. For example here, from 0 to t, from 0 to 2, we have ft equals to 1. Okay, t from 2 to 4, we have the ft is equal to 2. And so on. Okay, t greater than 4, we have ft equals to 3. So this one, you need to combine the integral. Okay, so here Laplace of ft is equals to integration from 0 to infinity. Okay, the first one is 1, sorry, not 0 to infinity, 1. Okay, exponent negative st, ft is 1. Okay, what is the limit from 0 to 2? Look at the limit from 0 to 2. Plus, next, continue, is 2. Next is 2. 2 exponent negative st, look at the limit. It's from 2 to 4. Plus, next is 3, right? The function is 3. From 4 to infinity because it's greater than 4. 3 exponent negative st. Okay, don't forget the dt. Okay, so you need to get this integral correctly. This determine the ft 1, 2, 3, and this determine the limit of the integration. Okay, the limit determine the limit of integration. So it must be up to infinity. Okay, the first integral will be exponent negative st divided by negative s from 0 to 2 plus 2 exponent negative st divided by negative s2 from 2 to 4 limit plus 3 exponent negative st divided by negative s, but the limit is from 4 to 8. So be careful, yeah. So now we can solve it. So we substitute the limit, we will get exponent negative 2s divided by negative s minus exponent negative 0 to 0, 0 lah. Exponent 0 divided by negative s. Okay, the first term plus 2 exponent negative 4s divided by negative s plus negative, okay, so it become minus become positive, negative s, 2s divided by negative s, and then plus, okay, the next one is 3 exponent negative infinity divided by negative s minus 3 exponent 4s divided by negative s. So we need to solve this integral, okay, simplified. So for now it can be 1 here. Okay, let us see what we can combine here. Okay, we look at the term. So here is 3 exponent infinity, negative infinity, so it means 1 over exponent infinity, so this one is 0. So let's combine the term with negative and with exponent power negative 2s. So this negative 1 and 1 will be exponent negative 2s divided by s. Okay, this and this. And then this one plus 1 over s, this term. And then negative 4s with negative 2 with positive 3. So you will get it equals to minus, this one is negative, negative here. Yeah, negative 3 and positive 2, negative 2 with positive 2, negative 2 with positive 3, positive, exponent negative 4s divided by s. So this one should be correct, yeah. Okay, that's it. So if it's this form of function, okay, it's piecewise function, you need to separate the integral like this. So this is an exercise for you to complete. Please submit the exercise 3.1. Okay, I've shown the example just now. It's similar to this exercise. Okay. So actually, what we have learned before, okay, on definition of Laplace transform has been summarized in this table. Okay, you can get straight away the Laplace transform from this table, okay, without using the definition. For example, if you are a, okay, if you have a number a, so when you perform Laplace transform, it will always be a over s. For example, if you want to find Laplace of 2, it will be 2 over s. Laplace of 3, 3 over s. Okay, they already summarized it in this table. The same thing for t power n. Okay, for example, you have t power 2. For it will be 2 factorial divided by s power 3. So it will be 2 over s power 3. Okay, you need to know what is your n. Next, for exponent, it always 1 over s minus a. For example, you have exponent 2t. So it will be 1 over s minus 2. Exponent negative 2t, it will always be s minus s plus 2. Okay, because negative become positive. The same thing for sine, cos, sine h, cos h. Okay, we just follow the formula here. We just change the a. Yeah. S maintained because we want the Laplace transform. Laplace meaning we change from function t to function s by using an appropriate definition. So in this table, they already summarized it for you. So sometimes we just need to use the table. If you are not asked to use the definition, you just straight away use the table. Okay, let us do this example. So by using the table of Laplace transform, okay, just the table. Find the Laplace transform for the given ft. Okay, a, the Laplace of 5. Okay, remember just now, it's Laplace of a is always a over s. So a now equals to 5. So you should get 5 over s. That's it. For b, ft exponent negative 3t. Exponent 3t. So now if Laplace of exponent at, just now we have 1 over s minus a. So what is a here? A is equals to 3. So it will be 1 over s minus 3. Wow, as simple as that. C, if cos t, what is it? The Laplace of cos at will be, okay, from the table it is s divided by s squared plus a squared. So know your s, know your a. Your a now is equals to 3. So Laplace of cos 3t is equals to s divided by s squared plus 3 squared, okay, which is equals to s divided by s squared plus 9. That's it. Very simple. Okay, for d, so this is t power n. Okay, how to get t power Laplace of t power n? So right here, Laplace of t power n will be n factorial divide by sn plus 1. So Laplace of t power 3, okay, equals what? N equals to 3. So it will be 3 factorial divided by s. N plus 1 is 4. So t factorial is 1 times 2 times 3, which is 6. Okay, the function is the factorial function is in your calculator. 6 over s4. Okay, so how about e? E is sine. So Laplace of sine. Okay, from the table, Laplace of sine at is equals to a divided by s squared plus a squared. So your a now is 1 over 2. Okay, a equals to 1 over 2. So the Laplace will be 1 over 2 divided by s squared plus 1 over 4. Okay, and then you can simplify it like this: 1 over 2s squared plus 1 over 4. Okay, or you can simplify it more, but I'll stop here. Okay, how about f? T squared exponent t is also in the table. It will be Laplace t squared exponent t. Okay, from the table it will be n is 2. Okay, n factorial divided by s minus a, n plus 1 factorial. So it will be 2 factorial divided by s minus 1, n plus 2 plus 1 is 3. So the answer is 2 over s minus 3 cube. Okay, that's it. It's very simple. Just look at the table. So if you're having problem on understanding how to look at the table, just let me know. Okay, so that's it for the time being. I'll just stop here. Okay, So we learn on the definition of Laplace transform and also how to find Laplace using table. Remember, if it's not stated, you can use the table. If it's stated to use the definition, you must use the definition. So this is exercise 2. I want you to submit as exercise 3.2. Okay, just look at the table.